Let us help you answer some questions to do with waves. Now these are foundation questions from the Edexcel Paper 1, but they'll be good for higher, and they'll also be good for any exam board, because all exam boards study waves. And this is worth 39 marks, so you can see over the last couple of years they've asked quite a number of questions to do with waves. Question 1. The speed of sound in air is 300 meters a second. The speed of sound in water is 1,500 meters per second. Calculate the ratio of the speed of sound in air to the speed of sound in water. We'll just do the speed of sound in air, which is 300, and you can just divide that by the speed of sound in water, which is 1,500. You can simplify that to 1/5, which is 0.2. If that's not how your teachers show you how to do ratios, you could do 300 to 1,500, and then you can simplify that as 1/5. That would be fine as well. Question 2. Blue light has a wavelength of 470 nanometers. So remember, a nanometer is times 10 to the minus 9. And a frequency of 6.3 times 10 to the 14 hertz. Calculate the velocity of blue light. So the velocity is frequency times by wavelength. So just pop the numbers in. So frequency is 6.3 times 10 to the 14 hertz. Multiply that by 470 times 10 to the minus 9 meters. And that equals 2.96 times 10 to the 8 meters per second. Question 3. A water wave has a wavelength of 0.25 meters and a frequency of 1.5 hertz. Calculate the wave speed. Right, it's exactly the same as the question you've just done. This is what I'm saying. They use the same questions or similar each year. In a previous year this was worth 2 and it's still worth 2, yet it's easier this year because you haven't had to convert the nanometers. So that's a win. So speed is frequency times by wavelength again, and just that equals 1.5 hertz times by 0.25 meters, and that equals 0.375, and that'll be meters per second. Question 4. A man throws a stone into a pond. The stone makes waves that spread out in circles. Figure 6 shows some of the waves. Which one of the following changes is correct as the waves spread out? The amplitude is higher. No, that's not right. The amplitude is the height of the ripples. So if you've ever chucked a stone into a pond, you'll know the ripples get smaller. I've showed a picture here. So at first the ripples are nice and high, and then the ripples are smaller as they get further away. The height of the ripples. The frequency is higher. Nope, the frequency just stays the same. The wave front is longer, right? The wave front is the distance from one wave to the next wave. Now on this picture, it looks like the wave front is the same. But if you kept on drawing, the waves would get further and further apart, like this photograph here shows. I've got this off the internet and popped it on, just to prove that what I'm saying is correct. So the answer's C. D, the period is longer? No, that's the amount of time taken for the wave. No, that wouldn't change. Part 2. The stone hits the water 4 meters from the bank, so that's a distance. The wave speed is 0.7 meters a second, so that's a speed. Calculate the time, so time is question mark, for the wave to reach the bank. Now this is something that I often do. Write down what you know when you know it. So we've got D and S and we want T. So is there an equation that links DS and T? Yes, there is. Speed equals distance over time. So rearrange that to get the time. So therefore the time is going to be the distance divided by the speed. Make sure you can rearrange equations. And that equals 4 meters divided by 0.7 meters per second. And that comes out as 5.71 meters. Now that number there was to 1 decimal place, but that number there was to 2 decimal places. So always do your answer to the greatest number of decimal places that they gave you the number to. Part 3. The wavelength of the waves is the distance between one wavefront and the next. Use the diagram to find the wavelength of the waves. Right, so you can see the wavefront is the line. So that's where the wave starts. So you've got 1 wave, 2 waves, 3 waves in 2 meters. So 3 waves in 2 meters. So therefore 2 meters divided by 3 waves means that each wave is 0.67 meters. And that's your wavelength, the length of one wave. Part 4. There is a cork which bobs up and down in the water as the wave goes past. Explain how this shows that the wave is transverse. So a transverse wave goes like that. And if you've got a cork, as the wave goes past, the cork will move up and down. And that's the wave travelling past there. And this is at 90 degrees. So what we say is that the vibration of the cork is at 90 degrees or perpendicular to the direction of travel. So that's our standard definition for a transverse wave. The cork vibrates at 90 degrees or perpendicular if you prefer. To the direction of travel of the wave. Question 5. A teacher takes a group of students onto a sports field to measure the speed of sound in air. The teacher fires a starting pistol. It produces a loud bang and a flash of light at the same time. The students take measurements. Describe how the measurements are made and used to determine the speed of sound in air. You may draw a label diagram to help with your answer. 6 marks. Right, well, as I say to my students, base your explanation on the calculation. So if you're going to measure the speed of anything, you need to measure the distance and divide it by the time. So, measure distance. Say what you're going to measure it with. With a trundle wheel. Measure time. With what? With a stopwatch. And then calculate speed by doing distance over time. Now that'll get you 5 marks, but it's worth 6. So let's explain a little bit more to you. if the teacher is over here with a gun and there's a flash and a bang, the light is going to travel at 300 million meters per second. So that flash is going to get over to this student at more or less the same time as the flash was at the teacher. However, the bang, which is sound, only travels at about 330 meters per second, so approximately 1,000,000 times slower. So if the student starts the stopwatch when they see the flash, and then they stop the stopwatch when they hear the bang a little bit later, that'll tell you how long it took for the sound to travel that distance. Now this is the thing, if this student is only standing like 100 meters away, it's only going to take 1/3 of a second for the sound to travel, which means the student needs to start the stopwatch and then stop it very, very quickly. And that's going to be a human error, because the average reaction time of a human is 1/4 of a second, which is comparable to the 1/3 of a second that we're trying to measure. So what you tell the examiner is that this person needs to be standing at least 300 meters away from the teacher, so that it takes approximately a second from starting the stopwatch to stopping the stopwatch. So have a large distance between the teacher and the student. To make measuring the time easy. If in doubt, you could just say get them to repeat the readings and take an average. Or as I've already said, start the stopwatch when you see the flash and stop the stopwatch when you hear the bang. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 different ways that you can answer it there, just for 6 marks. But I would probably be using those first 6, because they're the easiest to remember. Question 6. Sound waves are longitudinal waves. Water waves are transverse waves. Describe the difference between longitudinal waves and transverse waves. Well, once again, it's very similar to the question that we had previously. Transverse waves go up and down, so their vibrations are at 90 degrees or perpendicular to the direction of travel, whereas longitudinal waves, the wave travels that way and the vibrations are also in the same way, backwards and forwards, so that's what we call parallel. So transverse waves, vibrations are at 90 degrees to the direction of travel. And longitudinal waves, vibrations are parallel to direction of travel. So you could actually get 4 marks because that's 4 pieces of information. Question 7. The speed of light is 3 times 10 to the 8, so that's our speed. The wavelength of yellow light is that, so that's our wavelength. Calculate the frequency. So it's the 3rd time we've saw this question. They've made it worth 3 this time because they're asking you to state the unit. Well, frequency is measured in hertz. So we'll pop that in straight away. There's an easy mark. They've even kindly rearranged the equation for us this year. So pop the numbers in. There's your speed, 3 times 10 to the 8 meters per second. And the wavelength was 5.8 times 10 to the minus 7. And that equals 5.17 times 10 to the 14. Now they've only gave the numbers to 1 decimal place, so we'll do it to 1 decimal place as well. So that's 5.2 times 10 to the 14. Question 8. Figure 4 shows a wave on the sea moving towards the beach. Which one of these is correct? The amplitude is the distance between the waves. Nope, that's wrong. That would be the wavelength is the distance between 2 waves. Frequency is the number of waves arriving at the beach per second. Correct. Let's just check the other ones are wrong. Speed is the number of waves arriving at the beach per second. No, that's the frequency. And wavelength is the height of the wave. No, wavelength is the length of the wave, as it says. Haha. Question 9. Which one of these is a longitudinal wave? Gamma, no, that's transverse. Infrared, no, that's transverse. Radio, no, that's transverse. Sound, yes. All electromagnetic waves are transverse. In fact, there's very few waves that are longitudinal. Sound is one of them, and if you're doing triple science, there's an earthquake wave called a P wave, which is also longitudinal. So pretty much all the other waves are transverse. Question 10. Microwave ovens use microwaves. Figure 1 shows a slice of bread that has been in a microwave oven. Right, it must be from the side. The dark spots are caused by the microwaves. The spots are half a wavelength apart. A technician measures the distance between P and Q to determine the wavelength of the microwaves. Which one of these is the wavelength measured using this method? Right, so from P to Q, that is half a wavelength. That's what it said, half a wavelength. So if we double that, then that's a full wavelength. So from P to Q, that's from just over 2 centimetres to just over 8. So that's 6 centimetres is half a wavelength, which means that a full wavelength would be 12. There we go, the answer's C. So that's a case of making sure you read the question correctly. Part 2. Describe how the technician could obtain a more accurate value for the wavelength from figure 1. Right, well, what's he using to measure it? Centimetre ruler. Why not get a ruler that measures millimetres? And this one's always the same. Instead of just measuring the distance from one dot to another, why don't we measure the distance between multiple dots? And then we'll be able to take an average. Question 11. A man throws a stone into a pond. Devise a method of measuring the frequency of the waves. Right, so base your explanation on your understanding of the word frequency. So that's how I always start off. What is the definition of frequency? Well, frequency is the number of waves per second. So if he counts how many waves there are in a certain amount of time, hitting the riverbank or a certain position, and then he can just divide how many waves he saw by the amount of time it took. So use a stopwatch to count how many waves there are per second. Or use a stopwatch to count how many waves there are in a certain amount of time. And then frequency equals number of waves divided by the amount of time. Question 12. Figure 2 shows water waves spreading out from a source. Hey, they love the water waves questions. A student measures the wavelength of the waves. He uses a ruler to measure the distance from one crest to the next crest. Explain how to improve the student's method for measuring the wavelength. Right, well, that's going to be tricky, measuring that. So why not take a photograph and then make sure the ruler is in the photograph itself, and then you'll just be able to see the distance from one wave to the next. Or even better, once again, if they measure multiple wavelengths, and then they can get an average for the wavelength. So measure across several waves. So you could measure, there's one wave, two waves, three waves. It'll be much easier to measure across the three waves. Then once you've got the three waves, divide that length by how many waves there were. So just say that was 15 centimetres. That would be 15 centimetres divided by three waves. So the wavelength of one wave would be 5 centimetres. I hope that makes sense. And that's always the way that you make it more accurate. Question 13. A sound wave in air travels a distance of 220 metres in a time of 0.7 seconds. So we've got distance and we've got time. State the equation linking speed, distance and time. Well, it's the same question again. Speed equals distance divided by time. That's why you've got to make sure you know your equations. Calculate the speed of the sound wave in air. So speed equals the distance was 220 metres divided by the time, which was 0.7 seconds, and that equals 314.28. Well, 0.285 really. Now they've done it to 2 decimal places, so we'd better do ours to 2 decimal places. So that's 314.29, because the 5 obviously rounds the 8 up to a 9. Question 14, the last question. Figure 4 shows a wave on the sea moving towards a beach. Well, we saw this picture in question 8. So they love using the same pictures each year as well, sometimes. Part 1. State the relationship between the speed, frequency and wavelength. I mean, Howie, How many times have we saw this now? Speed equals frequency times by wavelength. That's the wave equation. You'll sometimes see it as wave velocity equals frequency times by wavelength. A water wave has a frequency of 0.4 Hz and a wavelength of 1.2 meters. Calculate the speed. Free bread. So speed equals frequency times by wavelength. So that's 0.40 Hertz times by 1.2 meters. And that equals 0.48 meters per second. Right, now as I say to my students, I need you to be feeling confident when you go into that exam hall. Now, hopefully you do feel confident, because by practicing these questions, you can see it's the same questions that come up all the time. They just ask them in a slightly different way. Alright, so I hope your confidence is being built by watching these videos. I've got more on the way. Smash that like button, subscribe to my channel, and I'll see you in the next one. Work hard, be nice, and bye for now.